Lesson 32, altitudes and medians of triangles. To find the median, you connect a vertex of a triangle with the midpoint of the opposite side. So if we draw a triangle, find the midpoint, so we're just eyeballing it for this. If you had to graph, you would actually find the actual midpoint. So the intersection of all three medians is called the centroid. The centroid is the point of concurrency. That just means the intersection point of the three medians. One thing that's cool about the centroid is it's the balancing point. So it's like the center of gravity there on the centroid. Okay. There is a centroid theorem.
Okay, I just have
Yeah.
a question.
Mm-hmm.
Would the top vertex of a pyramid be its centroid? Or would it be like inside?
I don't know how you would find it because a centroid is for the two-dimensional figure triangle. So I don't know if there is such a thing for three-dimensional.
Okay.
I'm not positive
Just
about
curious.
that. Okay. So there is a theorem with the centroid. And it says that any median drawn, so if this is your vertex, we'll call it A, and you draw down to the midpoint of opposite side, and we'll call that Y. And then W, we'll call that the centroid. Okay, so we're just taking one of our medians. So this whole thing, and leave some space there just like I did. This is your median. So the length of AW is 2/3 of the total length of the median. And then the WY is the rest, so 1/3 of the total median. So the theorem actually says from the vertex to the centroid, AW is going to be equal 2/3 of the entire median. And then the smaller part from the centroid to the midpoint will be 1/3 of the median. And you'll have lots of math to do with that. Yes, Samuel.
I'm not sure what exactly.
So I took this,
It just says
see
AY.
this?
It says AY, not W.
Well, no, I'm wondering if
WY.
a bracket between the entire thing or just to
This,
from A
this
to
entire
Y
thing
centroid?
from A to Y is the median. From A to W will be 2/3 of the whole median, and 1/3 of AY will be WY.
Oh,
So what I did is I took this particular median, but it's true for all medians. I just took this vertical median and just put it right there to show you that from the vertex to the centroid's 2/3,
Okay.
and from the centroid to the midpoint of the opposite side is 1/3 of the whole median. And that's just this called the centroid theorem. Okay. The altitude of a triangle is the perpendicular segment from the vertex to the opposite side. It does not necessarily bisect the side. It's just perpendicular from, so it's a segment from the vertex to the opposite side. So let's do another kind of super tall one here. So when we go perpendicular, so we're just going to go straight down for this one. And then this one will be perpendicular like right there, maybe. And then right there. So this particular line is called the altitude. And then the intersection of all three altitudes is called the orthocenter. And it's the point of concurrency of all three altitudes. And the orthocenter doesn't have to be out, inside the triangle. So on a right triangle, the orthocenter would be right at the right angle. Okay? And then on an obtuse triangle, the orthocenter is actually outside the obtuse angle. And there's a picture in the book, example 3, shows all three, except for the right. Wait. No, the right triangle orthocenter is right at the right angle. It does show that. Okay, that's the end of the lesson. We're going to do some practice on this.